Hey everybody, welcome back. This is M035, which is College Algebra. This is College of the Sequoias. And today we're continuing discussing other ways of looking at linear equations. In the last section, we looked at slope-intercept form, y equals mx plus b. Today we're going to look at something a little bit different. Let's take a look at the point-slope form of an equation and some graphing. Okay, so to use the point-slope form of an equation, we require two things. This requires, well, A, we need 2 points, and B, we can do 1 point and the slope. Okay? And the point-slope form of the equation is y minus y1 equals m times x minus x1. All right? So to use this, notice that we need m and 1 point. If we don't have m, a second point is necessary. And from that, we can use the slope formula. Recall m equals y2 minus y1 over x2 minus x1. All right? And actually, the point-slope form of an equation comes from the equation for the slope. And I'll show you. Well, I'll show you where it comes from. All right, pause this if you need it up longer. So I'm going to start with the m on the right. Let's start with m over here. We've got y2 minus y1 over x2 minus x1. And step 1 is clear fractions. So to do that, I'll multiply by the common denominator, which is x2 minus x1. I'll multiply both sides by x2 minus x1. On the left-hand side, they cancel out, numerator and denominator. And we're left with y2 minus y1 equals m times x2 minus x1. And now drop the second subscript. The 2's. And we do that, we've got y minus y1 equals m times x minus x1. So it comes directly from the equation of the slope. Let me look at some examples. Let's say we have the point 3, negative 5, and a slope of negative 2. So we have y minus y1 equals m times x minus x1. And since we have that point, we're just going to use this as our x and our y. So x1 equals 3 and y1 equals -5. And I'm just going to replace those values in there. So x1 is 3, it goes over here. Y1 is -5, it goes right there. And m is -2, it goes right there. Just substituted the values in. The left side turns into y plus 5 minus m negative, it's positive. And here I'll distribute -2 times x is -2x. -2 times -3 is +6. And if I subtract 5 from both sides, I get y equals -2x plus 1. Note that you can do this with y equals mx plus b also. As I'll show you on the next page. So we're going to use that same point, same m. So y equals mx plus b. And now I'm going to, x is 3, y is -5, m is -2, and we'll solve for b. And then plug b back in. So I've got y is -5 equals m is -2, x is 3, and then I've got plus b. I'll clean it up a little bit. We've got -5 equals -2 times 3 is -6 plus b. Now add 6 to both sides, and I get -5 plus 6 is +1 plus b. Now I'll take that and plug that back in along with m. And I get y equals m is -2, x, and then b is +1. And that's what we got right there. Okay. So point slope form or slope intercept form of a linear equation can be used when we have a point and a slope. To find the equation of the line. And the only other real form that we actually write this in, I could write this in if I add 2x to both sides. I get 2x plus y equals 1. And that's the standard form of the equation. And standard form ideally has no fractions. So if you have fractions, clear them out using a common denominator. All right, let's take it up a notch. In this example, we're not given the slope. We're given 2 points. Point P is -4, 3, and Q is 5, -1. And the goal or objective, write the equation in standard form. So when we have 2 points, what we have to do first is find the slope. And then to use either equation, use either formula. Since we're working on the points, or we're introduced the point slope form, I'm going to use that. So step 1, M, let's call this point 2, and this will be point 1. And so I've got M equals y2 minus y1 over x2 minus x1. And y2 is the y coordinate of point 2, which is 3. Y1 is the coordinate of point 1, which is -1. X2 is the coordinate of point 2, which is -4. And x1 is the coordinate of point 1, which is 5. So I get 3 minus -1 on top is 4. -4 minus 5 is -9. And I like to have the negative out front, so I'm going to put it out front. And then I'm going to use the point slope formula. Again, that's y minus y1 equals m times x minus x1. And we can pick either point here. I'll use the top one. Y minus the y value is 3. And then we have m, which is -4 over 9, times x minus -4. So I used point 2 in that to get that. So I've got y minus 3 equals -4/9 over x plus, or times x plus 4. Now I could distribute the 9, but the standard form has no fractions. So it's actually clear, it's easier to clear them now. And that means multiply by the LCD. The LCD is the only denominator we have, is 9. I'm going to take both equations and multiply by 9. Distribute here, I've got 9y minus 27. The 9 here cancels with that one, and I got -4 times x plus 4. And now we just solve. Distribute the -4. And I'll add 4x to both sides. And I'll add 27 to both sides because I'm trying to get into the standard form. Equal sign comes down. I've got 4x plus 9y. And on the right, -16 plus 27 is 11. You will get the same thing. I recommend you try it. Try getting the same thing using point 1. Same equation using point 1. you should get 4x plus 9y equals 11. All right. So, pro tip. Whether you have 2 points or 1 point and the slope, if one of the points is the y-intercept, you know, 0, comma y, definitely use the slope-intercept form of the equation. It's easier. And that was y equals mx plus b. So I'll give you an example. Our objective here is write in slope-intercept form and graph. And graph the line. And we're going to use point P is negative 2, comma 4, and point Q is 0, comma 2. Now note, that is the y-intercept. And we have 2 points. We need the slope first. So m equals y2 minus y1 over x2 minus x1. I'll call that point 2 and point 1. So I've got y2 is 4, and x2 is negative 2. And then y1 is 2, and x1 is 0. So I've got 4 minus 2 is 2 over negative 2. I get a slope of negative 1. Since that's the y-intercept, this is the b. But if you don't believe me, we have y equals mx plus b. We plug in the negative 1. Y equals negative x plus b. We plug in 0, 2. 2 equals negative 0 plus b. So b equals 2. And we'll plug it back in. And we get y equals negative x plus 2. All right. It asks us to graph it. The y-intercept is up 2. And the slope m is negative 1, which is negative 1 over 1. So I can go down 1, right 1. And connect the dots. All right. So let's do a little. There's more stuff we got going on in this section. Our first goal is going to be find the equation of this line from the graph. Just drawing the graph right now. And notice how every fifth line I do, I make longer. Makes it a little bit easier to figure out where my points are. And we're going to have a point here, and we're going to have a point here. And the line goes like that. All right, so it looks like the y-intercept is right here. The y-intercept is crossing the x or the y-axis at 8. The y-intercept is 0, 8. And it looks like I'm going right 3 and down 8. So rise over run, we have a rise of -8, a run over 3. If I put that into an equation, I got y equals -8 over 3x plus my y-intercept is 8. And now we're going to do two different things. We're going to graph a line parallel to this one. That passes through 0, -3. So I got a point there, 0, -3. Parallel lines are like train tracks. Okay? And what that means is like train tracks. And on a graph, it means the slopes are the same. M1 equals M2. Same slope. Which means my equation is going to be y equals -8/3 x, and now my y-intercept is -3. And now I'm going to rise 8 and run -3. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. Connect the dots, and I got the parallel line. So that's parallel. Parallel track or parallel has the same slope. And the other thing we want to do is do the perpendicular line to the same point. Perpendicular line is we flip it. M1 equals 1 over M2. And change the sign. So flip the slope and change the sign. So M1 is -8 over 3. I'm going to flip it. I'm going to have 3 over -8. And then I'm going to change this sign, which means put a negative with it. And 2 negatives make it positive. M2 equals 3 over 8. Which means my equation is y equals 3 over 8x minus 3. And that means I'm going to rise 3 and run 8. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. And that's the perpendicular line. The way we indicate these with symbols, parallel, we use 2 vertical bars. So we'll say M1 is parallel to M2. And perpendicular looks like an upside down capital T. M1, or equation 1 is line 1 perpendicular to line 2. And flipping the slope and changing the sign, this is another way of saying it, is the negative reciprocal. So let me give you guys one to try. We can summarize a lot of stuff. So let's just list our equations that we have. We got y2 minus y1 over x2 minus x1 is our slope, m. And that led us to the point slope form, y minus y1 equals m times x minus x1. And when you distribute m and add a y1 to the other side, that will lead to the slope-intercept form, y equals mx plus b. And we also, things to note, parallel lines have the same slope. And perpendicular lines have negative reciprocal slopes. All right. If you only have 2 points, find the slope first using A up above. And then use either point and the slope in B or C. If you put it directly into B, equation B, the point slope form means it's shorter. It really is shorter. It's a little bit shorter because just solve for y at this point. If you put it directly into C, you have to use it to find the y-intercept, which is 0, B. and then plug it back in. Plug M and C or B into C. If you have 1 point in the slope, it's easiest to go directly into B. And if the point is the y-intercept, put it into C, the slope-intercept form. Camera froze up. Why? There it goes. All right. So let me give you a problem to work out. I want you to pause it when you're done and go for it. Find the equation of the line. Through the point. -10, 3. That is parallel, or that is two things. A, parallel to, and B, we're going to do perpendicular to. For both of them, 2x plus 5y equals 4. All right. Before you get started, the only thing we need from this equation is the slope. Once you have it, get rid of it. Don't look at it anymore, all right? Pause it, try to work this out. All right, I'll assume that you did. So I've got 2x plus 5y equals 4. Subtract 2x from both sides, and I get 5y equals -2x plus 4. I can either divide by 5 or multiply by 1/5 on both sides. If I do that, I get y equals -2/5 x plus 4/5. All I need from this is the slope, m equals -2/5. All right? So if I want to do the parallel line, let's look at both things. We'll do the parallel line first. The slope is the same, m1 equals m2. So I've got y minus y1 equals m, which is -2/5 times x minus x1. The only difference when we get to the parallel one is m1 is equal to -1 over m2, the negative reciprocal. So I'm going to use y minus y1 equals, I'll flip it over and I'll have 5 halves. Changing the sign makes it positive. And then x minus x1. My point is -10, 3. So I'll plug that in. Y minus 3 equals -2/5 times x minus -10 becomes a plus 10. And that's what we're going to have over here. Y minus 3, and the only difference is we have 5 halves there, x plus 10. So we'll distribute. Y minus 3 equals negative 2/5 x. Negative 2/5 times 10 is negative 20 over 5 is negative 4. Add 3 to both sides. And I get y equals negative 2/5 x minus 1. And that's the parallel line. The perpendicular line, we will distribute. I got 5/2 x, and then 5 times 10 is 50 over 2 is 25. I'll add 3 to both sides. And I get y equals 5/2 x plus 28. And that's it for 2.5. All done there. Pause it for a second. All right, so that wraps up 2.5. Let's take a look at 2.6. 2.6 is on the graphs of basic functions. And the first one we'll look at is called the identity function. You don't need to have that memorized. And since, remember, functions are f of x, y, and that's the same thing as y. So our identity function, f of x, equals x. Or equivalently, y equals x. So this may sound funny. It'll come clearer as we go on. I'm going to call my central point the origin, 0, 0. Right? And as we change x, we use the symbol, the triangle x. Triangle x is said as delta x, and it means change in x. So if I go up, or if I go right 1, I've got to go up 1. It's got a slope of 1. I go right 2, I got to go up 2. Still got a slope of 1. If I go left 1, I got to go down 1. If I go left 2, I got to go down 2. All right? That's my line. May not seem all that exciting right now. And so again, the triangle x is the change in x. You read it as delta x. And that means triangle y is change in y. So x goes, as I go 1 to the right from the center. When I say change, I mean change from center. Or the central point. Okay? This is going to be a pattern that we follow on all the graphs. Okay? So we're going to have a central point, and we'll look at changes in x and changes in y. If we look at the domain here, the domain is all real numbers. And so is the range. All real numbers. That's a simple graph. That's the most simple line you can have. Now we'll look at the squared function. When f of x equals x squared, again, we're going to use a central point of 0, 0. Three, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. All right, so let's look at a change in x versus a change in y. If I put in 1, x equals 1, f of x equals 1. If I put in x equals negative 1, f of x also equals 1. We square it, and the sign goes away. This is going to be true for all of them. We put in a positive or negative version. Since we're squaring it, the negative is going to go away. So I can go left or right 1, and I got to go up 1. And if I put in 2, left or right 2, I square 2, 2 squared equals 4. So we got to go up 4. If I put in plus or minus 3, negative 3 squared is 9, so plus 9. And we could keep going, 4, 5. This is going to be up 16, up 25. I didn't leave myself room to do all those. My central point is right there. From there, I'm going to go right 1, up 1. Right 2, up 4. And right 3, up 9. Do the same thing on the other side, except I'm going to go left for each thing I go up. Left 1, up 1. Left 2, up 4. Left 3, up 9. When we connect the dots, notice it doesn't make a V. It's got a curve to it. It's like a curvy V. This is the squaring function. And the shape it yields is called the parabola. And on the parabola, we call the center the vertex. All right? And it should look curvy. Should look curvy here. No corners. Don't make it look like a V. The domain, as I go from left to right, it keeps going all the way to the left and keeps going all the way to the right. So the domain is all real numbers. And if we do the range, I start at negative infinity, I go up, it doesn't hit the graph until we get to 0. And then it keeps going up. The range goes from 0 to infinity. It includes 0, so we'll use a bracket. The parentheses is to the infinity, and this is the same thing as y is greater than or equal to 0. our squaring function. Next up, square root function. I don't know if you can see that. This is the back of someone's test, and look, they drew a little dinosaur for me. All right, so the square root function. F of x equals the square root of x. We have our delta x or delta y. Notice if I try to use negative numbers, let's just go with -1. If x equals -1, f of -1 is the square root of -1, which was I. It was an imaginary number. So -1 goes to an imaginary number, which we can't graph. No. In fact, any negative number doesn't work. So the first value that works is 0. And when you take the square root, you get 0. This is our center point, or our central point. And if I can go plug in 1, 2, and 3, does it help me? Square root of 1 is 1. Square root of 2 is square root of 2, about 1.4. Square root of 3 is about 1.7. These are bad to graph, so maybe these suck to graph. But if we look at 4, square root of 4 is 2. And what made 4 work where the other ones didn't? 4 was a perfect square. So it's kind of best to use perfect squares. So I've got 1, 1. I go right 4. I go up 2. I'm rewriting it right there, so it's all on the same line. If I plug in 9, the square root of 9 is 3. 16 would be 4. Which means, let's plot those. What I'm doing is changes from the central value. Changes from central point. So I've got 0.00. If I have a change in x of 1, go right 1, I go up 1. If I have a change in x of 4, 1, 2, 3, 4, I go up 2. Change of x of 9 is way over here, I go up 3. And this is f of x equals square root of x. It's a function. This is different from this graph right here. Same points on top, but I have also points down below. This is a sideways parabola. This is x equals y squared, or y squared equals x. Notice if you take the square root of it, you get y equals plus or minus x, square root of x. And that's where the negative line comes, the values underneath come in. Well, no matter what x is, I got values down below. Notice the top half is the same. But this one down here is not a function because it doesn't pass the vertical line test. Okay? And this one looks like a sideways parabola, doesn't it? It looks like our squaring function sideways. If we go up here, both the domain and range go from 0 to infinity. There's no negative values on the square root function. Our next basic graph is going to be the cubic function or cubic function. Or also called the cubic function. Cubes all have the same side, length, width, and height. F of x equals x cubed. So again, we'll have a central point of 0, 0. And let's just make a list of the changes in x and changes in y from that point. And notice the way I get the central point is I just literally plug in x equals 0, f of 0 equals 0. That's where the central point I get comes from. Plugging what happens at x equals 0. What happens at x equals 0? Later on, we're going to show what happens as these graphs are different, but these are the base functions, basic functions. If I plug in 1 cubed is 1. If I plug in -1, I get -1 cubed is -1. And so I could kind of group these together. I could say plus or minus 1 on both sides. Plus or minus 1 leads to plus or minus 1. Similarly, if I plug in plus or minus 2, 2 cubed is 8. If I do the positive version, I get positive 8. And if I do the negative version, I get negative 8. And if we do plus or minus 3, 3 cubed is 27. Now, that's where it starts to get unmanageable. So, notice y gets really large, not very far from x. The center's there. I can do plus or minus 1. It goes right 1, up 1, left 1, and down 1. And this is why you do go out more than 1. That looks like a straight line, doesn't it? It's like I put the point, go just like that and have a straight line on the points. But if I put in the 2, I go up 8. If I put in -2, I get -8. So it kind of does this. It looks like a parabola going up on the right, but a parabola going down on the left. If we look at the domain and range here, it goes infinitely up and down. The left and right, it does the same thing, albeit much slower. So it's all real numbers, or we could say negative infinity to positive infinity. And, you know, it kind of, so what happens with it? It doesn't cross in a straight line. It comes in, when it crosses 0, 0, it kind of wiggles across. It wiggles. Wiggle, 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 yeah. Wiggle, 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 yeah. It's sexy and it knows it. It's sexy and it knows it. So it comes down, it's curving down, curve, 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 wiggle across. Now we did this square function and the square root function. Cubic function, we can do the cube root function as well. Let's take a look at it. F of x equals the cube root of x. Let me make that a little more pronounced, a little difficult to see there. Cube root of x, there we go. And the square root of x had a problem with negative numbers. Do we have a problem with negative numbers on the cube root? Twice. 0, 0 is still our central point. If I stick in 0, I get 0 out. If I stick in -1, the cube root of -1 is -1. So the negative numbers work. Cube root of 1 is 1 also. So I can do plus or minus 1 leads to plus or minus -1. And just like with square root, I only use perfect squares, only use perfect cubes for x. And sometimes it's easier just to go the other way, or use simple values of y. That requires recognizes that y equals x cubed and y equals cube root of x are inverse functions. We haven't gone over that yet, so let's just stick with what we have. The next cubed number, perfect cube, is 8, and the cube root of 8 is 2. I can also do plus or minus 27 leads to plus or minus 3. So big changes in x lead to small changes in y. Now, I'm not going to go out 27. That's ridiculous, but I can go out 8. 5, 6, 7, 8. And I need to go, the 8 goes with plus or minus 2. So my central point is 0, 0. I have a plus 1, -1, plus 1, plus 1, -1, -1, plus 8, positive 2, and -8, -2. So this one looks kind of like the square root function going to the right, but now it's got it going to the left like that. And again, it's got a wiggle. And just like the cube root function or the cubic function, the domain in range is infinity. All real numbers. A little bit more. The other base function that we'll use, basic function, is the absolute value function. F of x equals the absolute value of x. Our central point, plug in 0. I have 0. F of 0 is the absolute value of 0 is 0. If I plug in f of -1, the absolute value of -1 is +1. And that's the same thing as if I plug in +1, I get 1. So I've got plus or minus -1 leads to +1. And all it does, the absolute value is makes whatever the x value is positive. So plus or minus 2 will be +3, or +2. Plus or minus 3 will be +3. The y values, we don't have any negative y values, do we? We have negative x values, but no negative y values. If we plot our points, I go right 1, up 1. I can go right 2, up 2. I go right 3, up 3. If I go left 1, I got to go up 1. Left 2 is up 2. Left 3 is up 3. This one has a corner. Absolute value makes the V. Absolute value graphs look like these. All right. And that means it has a corner. The corner is actually called the cusp. And another way of writing this absolute value function, and it's the meaning of absolute value of x. F of x equals the absolute value of x. If x is less than 0, f of x equals negative x. And if x is greater than or equal to 0, f of x just equals x. That's the definition of the absolute value thing. This is like a split function. It acts differently on different regions. Notice that we do have an infinite domain. But the range has no negative numbers. It starts at 0 and goes up to infinity. Finally, let's look at one that's got a split. Let's look at something like this. F of x equals, it equals 2x plus 4 if x is less than 1, and it equals negative x plus 4 if x is greater than or equal to 1. These are called domain restrictions, when we restrict the function to be specific things on specific domains. So the key to this is graph these like two separate lines. Two different lines. On their domain. So for x less than 1, I'm going to use y equals 2x plus 4. And for x greater than or equal to 1, I'm going to use negative x plus 4. When we have something like this, where we have restrictions, where this boundary is, there's something goes on at x equals 1, we have different things. If we have an inequality like that or that, we're going to use hollow points. And if we have less than or equal to or greater than or equal to, we'll use solid points. So I'll graph this. All right, so I'm going to do the x is less than 1 here. The y-intercept is 4. I have a slope of 2, which is up 2 over 1, down 2, left 1, down 2, left 1. And at x equals 1, I have the inequality symbol. I'm actually going to use a hole. It's hollow there. This is y equals 2x plus 4 on the domain x is less than 1. And then for x greater than 1, I have the same point there, and it goes down 1 over 1. Since I can have the equality point, I can include that one. And it keeps going down 1 over 1. I don't have any values, so I don't actually cross the y-axis because x is restricted to being greater than 1, but I do use it to help me draw my line. So use 0, 4 to help draw y equals negative x plus 4 on x is greater than or equal to 1, but don't actually plot it. My line starts there and goes that direction. We have a solid point right there. That point's hollow, that point's solid. When we have stuff like this, graphs with gaps or holes are called discontinuous functions. And the hole is called a discontinuity. and they don't meet here. The lines don't meet. All right. That's kind of it for 2.6. Peace.